Okay, the video today, putting this in your notebook, labeling it with the date and the table of contents, calling it similar figures. Okay, if you need to pause the video, because I do tend to go pretty quickly, go ahead and do so, because I'm moving on. So, similar figures. We've been working on proportions in class. So the next step would be to take it into geometry, into something called similar figures. So in your book, in an excerpt from your book, what the heck similar figures are, if you have similar figures or similar polygons, those are shapes that have 3 or more sides. If you have 2 of these polygons and we call them similar, if they are similar, then 2 things have to happen. Okay, and this is the real technical terms here. Corresponding angles have the same measure. That's one thing that has to happen. And the second thing is that the lengths of the corresponding sides form equivalent ratios. So you might be like, oh my gosh, what does that mean? So the part to write down here is that if you have similar polygons, similar shapes, similar polygons, they're going to be the same shape, but not necessarily the same size. And in order for them to be similar, 2 things have to happen. 1, angles have to match up. They have to be congruent. They have to be equal. And 2, the other thing that has to happen is the sides, the corresponding sides are in proportion. So sides are proportional. So if I give you an example of what that looks like, here I have an example of 2 shapes, 2 polygons. In this case, triangles. And these 2 triangles, if I label them, I have triangle ABC here is actually similar, and this is the little mathematical notation symbol for similar. I would read that as similar to triangle F, and I'm putting this in order. If I went to B, B is equivalent to G, so G is going to come next, and then C is equivalent to H. So I can see that in both of these triangles, they are the same shape, but not necessarily the same size. If I look at their angles, angle A is equivalent to angle F, so those are equal. B is equivalent to angle G, and C is equivalent to angle H. So we have corresponding angles equal to each other. And then their sides are supposed to be in proportion. So if I go to AB, is 34 over, that goes with FG. AB corresponds with side FG. So 34 goes to 51, just as, let's look at a different set of sides, just as, let's go to AC, 40 compares with what over here? FH, 60, which is supposed to be the exact same ratio, equivalent ratios, as BC, which is 50, to GH, which is 75. And you might be like, man, those do not look the same. Well, if we were to actually calculate these out on a calculator and take 34 divided by 51, let's just see this quick. Okay, I just want to show you that they are. So if I take 34 divided by 51, I'm at 0.6 repeating. If I take my next one, which was 40 divided by 60, should get the same thing. And I do! And then the last ratio we had was 50 over 75, which is 0.6 repeating. So they all are equivalent to 0.6 repeating. These all are proportional to each other. They're all equivalent ratios. So we can say that these 2 triangles are similar. And you might be like, okay, what the heck? Why do I care about this? Well, you do this actually all the time with like your picture of your face. And then when you take your picture of your face and you make it bigger, do you want your face to be distorted? Probably not. So your face needs to be similar to the face you originally started with. Everything needs to be in proportion to itself. Okay? So let's go ahead and try an example of where we, a more mild problem here. Try one out together. So let's say I give you, in this example, triangle ACT and triangle ODG are similar. I tell you that, okay? So then in your mind, you would need to say, okay, if they are similar, their angles are congruent and their sides are in proportion. So here are the triangles. I even give you what they look like. And I have ACT. This is X. Uh-oh, we have an unknown. This is 32. This is 24. And then my other triangle, ODG, same shape, different size, ODG. And I tell you the side lengths here are 50, 30, and 40. Okay? Now, what do you think the question's going to be? The question's going to be, figure out what X is based on knowing that these are similar to each other. So if they're similar, their angles are supposed to be congruent to each other, and we aren't given any of the angles, and actually we don't even need the angles because we're trying to solve for a side. What we do know is that if they're similar, their sides are supposed to be in proportion. We should have equivalent ratios forming. So I'm going to take what I need to find, X, and say what does it relate to, what does it correspond to in my triangle over here? Well, X is side AC, side AC. And in my similarity statement, what are the first two letters of the next triangle? OD. So I need to go to OD, and that's 50. So X compares to 50. Okay, it's supposed to correspond to 50. Just as, now I'm going to pick another set of sides, and it's up to you which ones you want to do. So X compares to 50, just as, okay, I'm going to pick a different set of sides. Now let's say 24. Let's say I go to that one. Just as 24 compares to which one on this triangle? To 30. And now I have what we were working on in class. I have a proportion that I can try to figure out what the X value is. Okay? If you don't like the 24 over 30, you don't have to use those ones. You could use 32 compares to what? 40. So if you'd rather use those numbers, you could. It's up to you. Either way, I should get the same answer. So you're going to go ahead and try and solve that thing. And X over 50, let's just go ahead and try and solve it, equals 32 over 40. Are you seeing any relationship horizontally? No. Okay, so I'm going to erase that. Do you see a relationship vertically? No. So I'm going to erase that, but not the 2. Now before I keep going in the problem, I'm actually going to reduce this and then see if I see any more relationships. Okay? So I'm going to take each thing and I'm going to divide them both by, they both go into 2, they both go into 4, and they actually both go into 8. So I end up with X over 50 equals, if I reduce that side, 4 over 5. And now what's nice is when I actually reduce it, I don't have to use algebra because now I see a relationship between the 5 and the 50. So I need to get from the 4 to the X, so I'm going to draw my arrow this way. So to get from the 5 to the 50, I'm going to multiply by 10. So to get to the X value, I'm going to multiply by 10. So the unknown X value is going to be 4 times 10, which is 40. Okay, so in class, be prepared. We're going to work with proportions by doing what? By working with what's known as similar figures, similar polygons. In order to be similar, What are those two things that have to happen? Angles congruent, sides in proportion. Okay? All right, see you in class to practice.